Hello everyone. Today I'm going to be showing you the diamond kata done in Clojure using Speckle. So we're going to go ahead and start off by getting our tests running and opening our initial files here. Great, our tests are already running and failing, so that's good. We're going to start off by describing a diamond. And we want it to, just to start off basic, print off a diamond where the peak or the widest point of the diamond is an A. That's going to be an A followed by a new line and another A. And we need to use without string here because we're not testing the return value of the function. We're testing if the function is printing to standard out. So we're going to go ahead and define that function. And we don't need to worry about any arguments right now. We just need to return this string. I've got to make sure that's an N, not an M. And we have to make sure that we're printing that. Great. So our next test is going to be the next letter in the alphabet. So peak B. And that's going to have a leading space for the A and one space in between the B's. And that's failing. Now we actually do need to use a parameter there, so we'll call that peak. And let's go ahead and create a cond. We'll say if our peak is A, that we're going to print the same result from the previous test. And if our peak is B, we're going to print the diamond that has the peak B. So we just need that string. We'll just go ahead and grab it from our test so we don't have to type quite as much. Perfect. Okay, and then we'll just keep right on moving. Our next test is going to be for a diamond with the C as the widest point of the diamond. Oh, misspelled diamond there. It's going to have two leading spaces for the A, a leading space for B, an inner space for the B, no leading spaces for C, but three inner spaces. Go ahead and put that on the clipboard right away since we know we're going to need that. Test is failing, and then we'll just say if the peak is C, that we return that diamond with the C as the widest point. That gets our test passing, but we don't want to have a cond with 26 lines, one for each letter of the alphabet. So let's go ahead and pull in a vector of all the letters of the alphabet, and now we can loop through this vector as we construct our diamond and do this more programmatically. So we're going to go ahead and say that the depth of the diamond is equal to the index of our peak in this alphabet vector. So that means that the line numbers of our diamond are also going to be zero-based indexed. So the A is going to be 0, the B line is going to be 1, the C line is going to be 2, and so on. So we'll start off at 0, and there's already a pattern here that we can recognize where the diamond, the bottom half of the diamond, is the same as the top half. So we really only need to construct the top half. And so what's going to break our loop here is if our index is greater than the depth, we know that we've reached the letter that we need to get to and that we're going to print our diamond. So we're just going to stringify and concatenate our top half to the reverse of our top half to construct that full diamond, and we're going to print that to standard out. Otherwise, we're going to increment our index, and then we're going to conjoin onto our top half a string that's going to have our beginning spaces, our leading spaces. And those leading spaces are going to be equal to the depth of the diamond for the first line, for A, But then for every line after that, we have to subtract the line number that we're on in order to get the correct number of leading spaces. So we're going to do depth minus the number of the line that we're on. And then for the inside spaces, for the first line, which is B, line 1, I should say, remember we're doing zero-based indexing here. For line 1 with a B, we need 1 inside space. For line 2, we need 3 inside spaces. So it seems as though the pattern might be the number of the line that we're on plus that number minus 1. So 2 plus 1 being 3, 1 plus 0 being 1. Go ahead and clean that up. And then we don't need any of the original tests there. We just had those there as a reference. And we see we're getting 2 A's every time. We're getting double the amount of A's that we need. So we'll add a conditional saying that if the letter that we're currently on is an A, then instead we are going to add on to the top half still those leading spaces. So we're going to create a string with the amount of leading spaces, but then we only need to return the letter A with a new line character after it. Okay, that fixed that. Now we have the middle line of the diamond is duplicated, so we'll just do a rest there to drop the first line. That fixes it, but now we lost our A. So we're going to do an if statement saying that if the count of the vector called top half is 1, then we're just going to return the top half again. That way we'll get both A's. All right, everything passes, but now let's do some housekeeping. That block of code we'll create a helper function out of called toLine. That'll take the depth and the index, and we'll make sure that still passes. Okay, and then that form that's creating our full diamond, we'll call that toDiamond. And that'll take the top half. Perfect. We'll clean that up a little bit. That doesn't need to be on multiple lines. Make sure that everything still passes there. And while we're at it, the string for the A line, we'll call that toAline. And everything still passes. We'll clean up those trailing parentheses there. And now let's try something a little bit bigger. How about a diamond with an F as the widest point? So I'm going to go ahead and pull in from my clipboard here that diamond, make it a little bit easier on how much I have to type. And that's already passing. Perfect. So for our final test, let's try to demonstrate this in a REPL. We'll go ahead and make sure there's a JDK here so we can start the N REPL for line again. And once we get that REPL started, we'll just go ahead and print a diamond with a peak Z, since that's the largest diamond we'd ever need to be able to do. And there it is. Thank you so much for watching. I hope you enjoyed.